How is the moon going to help us to find aliens? Yes, we are going back to the moon. The Artemis program, formally established in 2017, is intended to send humans back to our natural satellite, but this time for good. Its main objective is to establish a permanent human presence near the south pole of the moon. Hello, I'm Dr. Alejo, and I have a confession to make. I grew up extremely jealous of the people from the generation that were alive to see in real time when humans set foot on the moon for the first time back in 1969. But if everything goes well, this year, 2026, we may get to witness the first crewed flight around the moon in nearly 60 years. And then, if everything goes really well, we will potentially see humans return to the surface of the moon by 2028. But what does this have to do with the search for extraterrestrial intelligence? Let's find out. Everything started with an inspiring and powerful speech back in 1962 by the then United States President John F. Kennedy.
Why climb the highest mountain? Why 35 years ago fly the Atlantic? We choose to go to the moon. We choose to go to the moon. We choose to go to the moon in this decade and do the other things. Not because they are easy, but because they are hard.
But don't get mistaken. Going to the moon, the Apollo program, was not really only about making scientific progress. This was the 60s, right in the middle of the Cold War between the USA with the now extinct Soviet Union. Going to the moon was really about showing to the world that capitalism was better than communism in every single way. This implied demonstrating that capitalism was able to produce the best engineers, the best rockets, and defeating once and for all the Soviets in the space race. A race that, until then, had been led by the Soviet Union when it achieved the first successful satellite launch, the Sputnik, in October 1957, and then putting the first human on Earth's orbit, Yuri Gagarin, in April 1961. There were 15 Apollo missions, starting with Apollo 1 in January 1967, that ended up with the tragic deaths of astronauts Virgil Grissom, Edward White, and Roger Chaffee. Apollos 4, 5, and 6 were uncrewed missions designed to test the rocket and technologies that would take humans to the moon. Apollos 8 to 10 had crewed missions taken to the vicinity of the moon, but without landing. And then, of course, Apollo 11, 20th of July 1969, and the source of my jealousy. The whole world witnessed how humans set foot on another world. More than 500 million people watched on television how the astronauts Neil Armstrong and Buzz Aldrin climbed down the ladder of the lunar module. For 2.5 hours, they explored the surface of the moon, collected samples, and took photographs before going back up to the lunar module and returning to Earth. Then, and a fact that some moon landing deniers seem to be unaware of or selectively ignore, who knows, 5 more missions succeeded in landing astronauts on the moon: Apollo 12 and Apollos 14 to 17. Apart from planting the American flag of the surface of the moon, these missions collected 382 kilograms of rock samples, which were brought back to Earth and analyzed by scientific labs all around the globe, helping us to improve our understanding of the composition and origin of the moon, as well as shedding light on its geological history. In addition, many instruments were left there: seismometers, cameras, lunar module ascent stages, laser-ranging retroreflectors. These last ones still work and have been vital for measuring accurately the distance between the Earth and the moon.
Preparing to fire laser at the moon. Make it so. There it is. There's the spike.
2.5 seconds for the light to return. That's the moon. We hit the moon.
Apollos 15, 16, and 17 left lunar rovers. However, it was never the intention of the Apollo program to establish a permanent presence of humans on the moon. The objective was to go there and safely come back. Space enthusiasts Some scientists and members of the public all around the world had a different idea though. They always saw the moon as a gateway to future exploration, particularly a gateway to Mars and other planets in the solar system. But remember that the main goal of the Apollo program was to win the space race. That is why after the last Apollo mission, Apollo 17, in December 1972, no more attempts or programs have been developed to go back. This changed in 2017 with the Space Policy Directive 1, signed by President Donald Trump, which was a continuation of the Presidential Policy Directive 4, established by President Barack Obama in 2010 with the aim of establishing the national space policy of the United States. The Space Policy Directive 1 established the Artemis program, although some people may argue that one of the main motivations for this new moon landing program is also to win a new space race, this time with China. The scientific objectives are quite clear and include the establishment of a permanent presence on the moon, specifically with the idea of using such presence to facilitate human missions to Mars. The Artemis program consists of 10 missions, starting with Artemis 1 in November 2022, when a successful uncrewed test was carried out. The objective of that mission was to test the Space Launch System, SLS, rocket, and the Orion capsule. The Artemis 1 team successfully placed Orion into a lunar orbit and then returned to Earth. Artemis 2 is scheduled to launch in 2026 and will take a crew of 4 astronauts on a trajectory around the moon. Unfortunately, the launch couldn't happen during the February window, given that during the loading of the fuel into the rocket's tank, engineers noticed a leak in the system. At the moment of this recording, February 2026, we are crossing all our fingers, so everything goes well on the launch window planned for March. Artemis 3, scheduled between 2027 and 2028, is planned as the first crewed lunar landing since Apollo 17. The astronauts will spend 6.5 days on the surface performing extravehicular activities near the South Pole of the Moon. The reason why the South Pole has been chosen as the landing site is due to the presence of the so-called cold traps, where water ice might be preserved. These are regions where the sunlight doesn't reach the surface, leaving deepest crater floors and valleys in permanent shadow at temperatures of around minus 175 degrees Celsius. Water from comets and asteroids' impact might remain in these regions. Water is of course critical for life support and fuel, and essential for building a sustainable long-term human presence. From Artemis 4, planned in 2029, and Artemis 10, scheduled for 2036, components such as gateway modules, robotic landers, and elements of the moon base will be transported to the surface of the moon. And once we have a permanent presence on the moon, we can start searching for aliens. As a matter of fact, scientists are already searching for aliens on the moon. In our previous video, Hunting for Alien Artifacts, which I invite you to check out, we explored how researchers are using machine learning algorithms to search for technology artifacts potentially left on the moon by an extraterrestrial civilization. This is being done by taking advantage of the ton of images taken by NASA's Lunar Reconnaissance Orbiter. In studies published in 2020 and 2024, researchers use areas of the moon's surface to train algorithms with the idea of finding potentially artificial objects. The algorithms are taught that a normal area is one that doesn't have any artificial objects, but a non-normal region is one that contains human-made artifacts, such as the Lunar Lander module from the Apollo 15 and 17 missions. Experiments have been conducted in which the algorithm has been fed with a large number of images, the majority of which did not contain any artifacts. For example, one experiment utilized a dataset of 8,000 images around the Apollo 15 landing site, including 10 images showing artifacts left by the mission's crew. At the end, the computer, trained using unsupervised learning techniques, successfully identified the landing module of the Apollo 15 mission. But all this is done remotely. What can we do once we have a permanent presence on the moon? Once permanent human presence is established, the fun can begin. One of the main problems SETI researchers face here on Earth is the presence of human radio frequency interference, or RFI. High false positive rate is not uncommon, despite SETI telescopes being located in radio quiet zones. But a radio telescope in the right place on the moon can shift things significantly. The moon is said to be tidally locked to the Earth. This means that one side of the moon is always facing the Earth, which also means that the other side, referred to as the far side, is always facing away from Earth. This far side of the moon is not bombarded by TV signals, defense radar systems, and satellite broadcasts, making it an incredible radio quiet place. In addition, there is no atmosphere on the moon. On Earth, the atmosphere filters a number of wavelengths, stopping them from reaching the surface. For instance, it filters harmful solar ultraviolet radiation. Without this filter, UV rays would cause significant damage to life on the surface. Unfortunately, this also implies that our radio telescopes can only receive a fraction of the entirety of the electromagnetic spectrum. But a radio telescope located on the far side of the moon would be able to access radio frequencies that are completely inaccessible from Earth. What does this mean for SETI activities? It has been argued by some SETI researchers that low-frequency radio waves may be an indication of large-scale technological activity. On Earth, the most powerful radio emissions are not our intentional communications, but the byproducts of civilization itself. Long-range radar systems, planetary-scale power transmission, over-the-horizon military radars, and high-energy particle accelerators. These systems operate at low frequencies precisely because those wavelengths travel long distances and interact efficiently with large structures. An advanced extraterrestrial civilization, especially one operating at a planetary or stellar scale, will likely produce similar emissions, not as messages, but as a technological leakage. But on Earth, the ionosphere distorts signals below 30 MHz and blocks some frequencies entirely. This hasn't stopped researchers from attempting low-frequency radio SETI. Some of these efforts have been done using the Murchison Wide Field Array. The MWA operates in the frequency range of 80 to 300 MHz on an exceptionally radio quiet site in Western Australia. The MWA represents the best Earth can offer for low-frequency radio SETI. However, a radio telescope on the moon would still beat it. Without an ionosphere, a lunar radio telescope gains access to ultra-low frequency radio signals that Earth-based instruments simply can't observe. Our atmosphere also does a really good job of protecting us from high-energy cosmic rays. These are normally produced by natural astrophysical sources such as supernova remnants, pulsars, and neutron stars, supermassive black holes at the center of galaxies known as active galactic nuclei, and gamma-ray bursts. On the moon, the lack of an atmosphere allows high-energy particles to reach its surface directly. Detectors can therefore measure their true energy's arrival directions and timing with far greater precision. Therefore, the moon is a unique place to search for anomalous high-energy signatures which deviate from those expected due to natural processes. If such anomalous signatures are indeed detected, this could potentially hint at those being produced by extremely advanced technologies, such as large-scale particle accelerators or exotic propulsion systems, which could be associated with advanced extraterrestrial technologies. But where would you actually build a radio telescope on the moon or place such detectors? Large single-dish radio telescopes rely on curved parabolic surfaces to focus incoming radio waves. If you think about it, what resembles this shape in nature? Yep, impact craters. The Lunar Crater Radio Telescope, LCRT, is a proposed 1-kilometer radio telescope designed to be built inside a crater on the far side of the moon. Instead of using the crater itself as a reflector, the concept involves suspending a lightweight wire mesh across the crater, using its natural curvature as a stable support structure. But the advantages of placing telescopes on the moon don't stop with the non-existence of an atmosphere or an ionosphere. Near the lunar poles, there are regions known as the peaks of eternal light that receive sunlight virtually all of the time. These have been flagged as potential places to place solar panels, which could provide a virtually permanent source of power. On the other hand, and as we discussed in the beginning, there are places where sunlight doesn't hit at all. These cold traps are permanently dark craters where water ice may be present, and that are a constant temperature below about minus 175 degrees Celsius. Instruments placed in or near these cold traps could operate with minimal thermal noise, dramatically increasing their sensitivity to faint infrared signals. This makes them an ideal location for infrared astronomy and, in the context of SETI, for detecting excess waste heat from advanced civilizations. These observations are particularly relevant to the search for hypothetical Dyson spheres and their variants. Dyson spheres, swarms, or rings are potential megastructures built by power-hungry advanced civilizations to capture the totality or the majority of the radiated energy from their home star. We explored this topic in our Kardashev scale video, which I will link in the comments section. But what if aliens are not using radio signals or built-in Dyson spheres? What if they are using exotic and advanced telecommunication systems? For example, although unlikely, they could be using gravitational waves to communicate. Gravitational waves could also be the unintended byproducts of large-scale engineering, such as manipulating massive objects, exotic propulsion systems, or conducting astrophysical-scale experiments. Gravitational waves are ripples in the very fabric of space-time caused by extremely violent and energetic processes. The merging of neutron stars or black holes are mainly the events that astronomers know are responsible for such waves. The first successful detection of gravitational waves occurred in 2016 when scientists at the LIGO Interferometer Gravitational Wave Observatory, LIGO, announced the detection of gravitational waves caused by the merger of two black holes. To do so, the observatory had to be constructed in an area where both seismic and human noise is reduced, given that the detectors are sensitive to vibrations from ocean waves, earthquakes, and even passing traffic. The Moon is one of the seismically quietest solid surfaces known in the solar system, and ideally suited for long-term installations of gravitational wave detectors. While this is highly speculative, which is what makes it such a cool idea, searching for gravitational wave patterns that deviate from known astrophysical profiles, such as unusual repetition, modulation, or energy scales, makes it another candidate to a SETI strategy done from the Moon. However, all the collected data will need to be processed and analyzed, and then, one more time, the characteristic features of the Moon seem to also provide an opportunity to face this challenge. The deep freeze regions we previously discussed, the cold traps, would allow the establishment of large-scale computing infrastructure. One of the main problems on Earth for large server farms is their cooling, but placing data centers in these extreme cold environments could dramatically reduce the energy required for thermal management, freeing more power to computation itself. What this means is that advanced AI algorithms could run directly on the Moon. This also means that large amounts of data won't need to be transmitted to Earth for processing, and that this processing could happen locally, close to the instruments collecting the data. This is actually an idea currently being explored by the company Lone Star Data Holdings. In March 2025, the company reported that it had successfully tested a tiny data center the size of a hardcover book. This micro data center was taken to the Moon on board of the Athena lunar lander from US space exploration firm Intuitive Machines. So, after nearly 60 years, we are going back to the Moon, and establishing a long-term presence will not only bring space exploration to a totally new level, but also astronomy. given the great observation conditions on the surface of Earth's natural satellite. I am sure that great discoveries will be made, and who knows, maybe this magnificent desolation place, as described by Buzz Aldrin, the second person to set foot on the moon, is the place where we will finally hear from ET. If you enjoyed this video, don't forget to like, subscribe, and press the bell icon so you don't miss future uploads. Also, don't forget to check my video on hunting for alien artifacts, where we explore the possibility of the existence of alien artifacts in the moon and in the solar system. Also, don't forget to check my book, A Story of More Than 5,000 Worlds, where we explore many SETI-related topics. That's it for now, and remember, the truth is out there.